Assalamu alaikum. My name is Ms. Farah Naveed. I'm a dental technologist. My today's topic is dental casting. I am sure after watching the video you will be able to understand better. Do like the video and support my YouTube channel by subscribing. Firstly, the definition of dental casting is the process by which a wax pattern is converted to a metallic replica of a prepared tooth restoration, or a dental restoration formed by the solidification of a molten metal in a mold. Prior to study casting, you must know about wax pattern, investment materials, and casting alloys. How a wax pattern is replaced by the alloy using casting procedure with the help of a customized mold. Few sample images are visible from wax pattern till casted alloy crown and bridge work. So, the wax pattern begins with the impression cast, used to create a model die of the prepared tooth. Make sure the finishing line of the prepared crown wouldn't disturb. A wax pattern of the restoration is created on the die. This pattern replicates the exact shape and size as prescribed by dentist or patient's tooth morphology as per crown cutting. The purpose of the sprue is to provide a channel for molten alloy to reach the mold. Once the wax has been burnt, investment left with hollow replica of wax pattern. The sprue is attached to the wax pattern. The diameter and the length of the sprue depend largely on the size and type of the pattern, the type of the casting machine to be used, and dimensions of the ring. Sprue is at the point of the greatest bulk of the pattern, that is the largest sectional area of the pattern. In order to avoid problems of distortion of thin patterns, now, sprue along with the wax pattern removed from die cast and are placed in a crucible former, casting ring and surrounded by an investment material. This material hardens to form a mold around the wax pattern. The procedure for forming the mold is described as investing. Once the investment has set for an appropriate period of 45 minutes to 1 hour, it is ready for burnout. Crucible former is carefully removed. Let's understand this image of cross-section of invested wax pattern in casting ring. The visible labeling are casting ring, wax pattern, sprue base, ring liner, investment material, and crucible former. What are casting alloys in dentistry? Dental casting alloys are metal mixtures used in the fabrication of dental restorations, such as crowns, bridges, and cast partial dentures, metal crowns, and much more. These alloys provide strength, durability, and corrosion resistance. Dental alloys must be able to flow smoothly into molds during the casting process to create precise, detailed restorations that fit the patient's tooth structure accurately. So back to the process. The mold cavity is formed by allowing the investment to set around the wax pattern and associated sprue former and sprue space. After allowing the investment material to set, the sprue base and former are removed and the wax pattern burnt out to leave the completed mold cavity. The choice of investment material depends on the type of alloy which is to be cast. The casting ring liner serves a dual purpose. It forms a relatively pliable lining to the inner surface of the rigid metal casting ring. This allows almost unrestricted setting expansion and thermal expansion of the investment. In addition, its thermal insulating properties ensure that the investment mold does not cool rapidly and contract after removal from the burnout oven. The temperature to which the investment mold is heated during burnout deserves special mention, since this controls the thermal expansion of the investment. For gold alloys, either a slow burnout at 450 degrees Celsius or a more rapid burnout at 700 degrees Celsius is commonly used with gypsum bonded investments. For nickel, chromium alloys, a temperature in the range 700 to 900 degrees Celsius is normal, whilst for cobalt, chromium alloys, a burnout temperature of 1000 degrees Celsius is typically noted. Heating of the investment mold should be carried out at a rate which enables steam and other gases to be liberated without cracking the mold. Also, it is important that the temperature to which the mold is heated is adequate to enable thermal expansion and inversion to occur, and that this temperature is not allowed to fall significantly before casting begins. Casting into a quartz-containing investment mold should be carried out with a mold temperature Above 650 degrees Celsius, if adequate expansion due to thermal expansion and inversion is to be achieved. This requires that the mold be heated to about 750 degrees Celsius. To allow for cooling which may occur before casting commences. For cristobalite, containing investment molds, the mold temperature should be above 350 degrees Celsius at the time of casting. And this requires heating to about 450 degrees Celsius to allow for cooling effects. The balance between the molten alloy temperature and mold temperature is important, in terms of producing a complete and accurate casting with a fine-grained structure. The alloy should be hot enough to ensure that it is fully molten, and remains so during casting into the mold, but should not be so hot that it begins to oxidize or that crystallization is delayed when it reaches the extremities of the mold cavity or causes damaging interactions with the mold walls. The mold temperature should be great enough to ensure complete expansion of the mold, and to prevent premature crystallization leading to incomplete filling of the mold by alloy, but not great enough for crystallization to be delayed for so long that a coarse-grained structure forms. Factors such as length and diameter of the sprue, and the distance of the mold cavity from the base of the mold all have an effect on the quality of the casting. For large castings, 2 or more sprues may be necessary in order to ensure that molten alloy is able to reach all parts of the mold cavity before solidifying. Casting machine. There are numerous types of casting machines are available. Centrifugal force applied to all of them, in which I am telling you about 2 of them. Number 1 is an induction casting machine, and number 2 is a centrifugal casting machine. In induction casting machine, the alloy is melted by an induction field that develops within a crucible surrounding by water-cooled metal tubing. The electric induction furnace is a transformer in which an alternating current flow through the primary winding coil and generates a variable magnetic field in the location of the alloy to be melted in a crucible. Once the alloy reaches the casting temperature in air or in vacuum, it is forced into the mold by centrifugal force, air pressure or vacuum. It is more commonly used for melting base metal alloys. On the other hand, in centrifugal casting machine, casting is done by melting alloy in a separate crucible, and the molten metal is forced into the mold by simple centrifugal force. The crucible is attached to the free arm of the casting machine. The casting machine spring is wound and locked. Once the heated casting ring is in place and the alloy is melted to casting temperature, spring is released which initiates rotational motion. Centrifugal force for pouring molten metal into a rapidly spinning investment mold in which centrifugal force from the rotation exerts pressure on the molten metal and form a precise, customized dental restoration. After casting, cleaning and finishing done. For the final metal alloy as per done as the wax pattern was fabricated. Thank you for watching. I hope you will keep in contact by commenting.